G'day, Year 7s. Alright, today is our fourth algebra lesson. We are looking at dividing algebraic expressions using the second index law. And don't forget, last lesson sounded very similar because we were multiplying algebraic expressions using the first index law. So these two lessons sort of in parallel with one another, and you're going to see some real similarities between the two, okay? So, learning intentions. Today you're learning how to divide algebraic expressions using the second index law, which is pretty much exactly the topic. My learning intentions really suck. I think I need to break them into smaller dot points. Alright, here is the second index law. It's very similar in nature to the first index law. Let me explain. What was the first index law? A to the m times a to the n equals a to the m plus n. So when you're multiplying the same bases with different powers, it equals that base to the sum of those powers. Okay? Now when you are dividing same bases, this is now the second index law, when you're dividing same bases with different indices, it is equal to that base raised to the power of the difference between those two indices. So when it comes to multiplying in algebra, multiplication of bases means addition of powers. Division of bases means subtraction of powers. And it's the power in the denominator, the numerator, minus the power in the denominator, m minus n. Okay? So, a very similar rule. Of course, that rule can be written in another way, and I can see that there's a mistake here actually. Let me fix that. That should be a divided by sign. We all know that a fraction is just another way of representing division, okay? So, a to the m divided by a to the n equals a to the m minus n. That's the exact same law here. They're not two different laws. They're just written differently, okay? All right. So now we're going to do a million examples, not quite as many as last time. And I've got the rule up here so that you can remember it. And we're going to cover a bunch of some general problems and then some special situations that pop up that you need to know how to deal with, okay? So, first one's real basic. And just like I did with multiplication, I'm going to set this out in a sort of unnecessarily long way, just to explain to you why the index law actually works, okay? So, w to the power of 5 divided by w squared. Well, w to the power of 5 in expanded form looks like this. 5 w's with multiplication signs between them, over w squared, which is w times w. Now we know from fractions that we can cancel things out in this situation. So 1w here cancels with 1 here. 1w here cancels with 1 here. There's nothing left on the bottom of the fraction except times 1, I suppose. What's left on the top is this, w times w times w, in other words, w cubed. And how do you get a 3 from a 5 and a 2? Well, you do 5 minus 2. And that's why our rule works. So, this whole step here is completely unnecessary, but it's a good thing to do right at the beginning of learning about this second index law because it shows you why it actually works. I don't like just giving you formulas and laws and saying, obey this law, it works because it works. I like to try and explain to you why these things work. Alright, so here we have one written not as a fraction but using a division sign. I always recommend actually that if you have a question like this that you convert it into a fraction straight away, just because for reasons that you'll learn later, that makes things a little bit easier to handle, okay? Okay, so that equals a to the power of 6 minus 2, which is 4. Nice and easy. All right, so now we have some coefficients in front of the t parts of those expressions, okay? Now, just like with multiplication, when coefficients came into play, we dealt with the coefficients separately and then we dealt with the variables. We're going to do the same thing here, all right? Now, 10 over 15. What is the highest common factor of 10 and 15? In other words, the highest number that divides into both 10 and 15. Well, it's 5, isn't it? So, to simplify the number part of that fraction, 10 divided by the highest common factor. So 10 divided by 5 is 2. And 15 divided by 5 is 3. There we go. We've simplified the number part of the fraction. Now we have to deal with the variables. Now there's a t on the top and a t on the bottom, both with different powers. A lot of students think on the right hand side of the equation here we need to put a t on the top and still a t on the bottom. That's not the case. Just one t on the top and then 5 minus 2, which is 3. Done. That's your answer. Okay. Alright, so now we have some a combination of positives and negatives starting to come into play with the coefficients. But that's cool because we know how to deal with that. A fraction is just another way of saying division, and we know that a negative divided by a negative is a positive. So our answer is going to be a positive. Alright, so now we forget about the signs. What is the highest common factor of 12 and 10? Well, that would be 2, and 12 divided by 2 is 6. And 10 divided by 2 is 5. So I've just halved those two numbers, really. I've got an a part on the top and on the bottom. I should probably say numerator and denominator, shouldn't I, since I'm a maths teacher. But I just put my a on the top. 12 minus 8 is 4. And it's positive 6 over 5. Because a negative divided by a negative is a positive. All right, here's another question. All right, so what's the highest common factor of 50 and 25? Well, that would be 25 itself. 50 divided by 25 is 2. And 25 divided by 25 is 1. Set myself up with a G, and the powers are 6, and remember there's an imaginary 1 there. 6 minus 1 is 5. Now, that 1 on the bottom of the fraction, is that doing anything useful? No. 2g to the 5 over 1 is just another way of writing 2g to the 5. So that looks real goofy. So we're going to that's not convention to have it written that way. Remember that word, convention? So we're going to write it like that. 2g to the power of 5. Whew! All right. So now we've got a couple of variables. That's okay. I reckon you already know what to do. We're just going to use the second index law a couple of times in the same problem. All right, positive 6 divided by positive 24. They're the coefficients. Well, positive divided by positive is, of course, a positive. 6 over 24, let's simplify that. Well, the highest common factor of 6 and 24 is 6 itself. 6 divided by 6 is 1. 24 divided by 6 is 4. All right, now I've got G's and H's going on. So I'm going to put a G and an H here. For the G's, I have in the numerator a power of 5 and in the denominator a power of 2. 5 minus 2 is 3. And for the h's, in the numerator I have a 3 as its power, and in the denominator I have a 2 as the power. 3 minus 2 is 1. Now, I'm going to change a few things because they don't follow convention. That is the correct answer. But a couple of things there look goofy. For one thing, h to the power of 1 is just h. And for another thing, 1g cubed h is the same as g cubed h. Okay, that 1 there isn't doing anything. So the answer is just g cubed h over 4. I mean, it wouldn't be wrong if you left those 1s there, but it wouldn't be following the conventional, normal way of doing things. We want our maths to look nice and pretty. All right. Now, something's going to pop up in this question that I want you to try. I'm going to pause for a moment, and I want you to try and think. When I tell you to pause, I want you to try and think back to last lesson and remember what it is. Something about a third index law, whatever that means, if you can remember. That'll help us finish this problem, okay? So, negative 9 divided by positive 30. Negative divided by positive is a negative, okay? And actually, that negative can go out the front of the fraction. When you have a fraction, if you have negative something over something, that is the same as, it's actually the same as positive, the thing on the top, over negative, the thing on the bottom, which is also the same as putting a negative out the front and just having those two as positive. This is the more normal way of writing it though, okay? Just a little side note there. All right, back to it. A negative 9 divided by positive 30 is going to be a negative. Now, 9 over 30, the highest common factor is 3, I think. Yes? Yes? Is that right? Let me think. Yes, that's it. Okay. I can't believe I had to pause to think about that. So 9 divided by 3 is 3. And on the bottom, 30 divided by 3 is 10. Now I've got A's and B's in the numerator and the denominator, so I'm going to set myself up on the top here with an A and a B. The powers on the A's are 7 and 7. 7 minus 7 is 0. And the B's powers are 7 and 2. 7 minus 2 is 5. All right, now I'm going to pause, and I want you to think about the next step. Third index law. Did you figure it out? Well, the third index law says anything whatsoever to the power of 0 equals 1. Which means this here, a to the power of 0, equals 1. So we get minus 3 times 1 times b to the 5. And you don't have to write this step if you can just do it in your head. I've run out of space here, so I'm going to put my equal sign over here. Well, minus 3 times 1, it was unnecessary to write that times 1, but I'm just trying to show you that a to the 0 always equals 1, anything to the 0. Minus 3 times 1 is minus 3, and there's a b5, so minus 3 b5 over 10. That's your answer. Okay. Whew! All right. These ones are fun. This is the first problem where we're combining the first and the second index laws in one problem. And later on down the track, in future years, maybe a little bit this year as well, there are about 7 index laws, and you can do all of those in the one problem. They're real tricky, but they're one of those things that are strangely enjoyable, okay? Now, as a rule, when you have things that need to be simplified in the numerator or the denominator before you can simplify downwards, what we do is simplify from left to right, and then we simplify from top to bottom, okay? So I'm going to treat the numerator as a separate problem. I'm going to imagine the denominator isn't even present. So this is just a problem using the first index law. I'm just dealing with the top here first, okay? All right. -2 times -4. Negative times negative is a positive. 2 times 4 is 8. Now I have a Q and an S and a Q and an S. So I'm going to set myself up with a Q and an S. 7 plus 2, the powers on the Q's, is 9. And the powers on the 4, on the S, sorry, 4 plus minus 2. And 4 plus minus 2 means 4 minus 2, which is 2. Okay? So S to the power of 2. Now I remember that there's a denominator. 16 SQ squared. Now it's a second index law problem, you see? And sometimes the thing on the bottom here, that expression there, sometimes that will look like the top as well, and you'll have to use the first index law on the top and the bottom before you can use the second index law, okay? All right, so now this is easy. 8 over 16, that's a half, right? So 1 over 2, set myself up with a Q and an S. And for the Q's, I have 9 minus 2, which is 7. Running out of space. And for the S, I have 2 minus the imaginary 1 there. 2 minus 1, which is 1. But once again, that answer looks goofy, because S to the power 1 is just S, and 1Q7S is just Q7S over 2. I'm going to shift that 2 over here. And there we go. We just did 8 examples, building our way up from easy to hard. And hopefully that was enough for you to be able to do the second worksheet. Once again, guys, when you're doing this second worksheet, it'll be called, what's it called? Second index law worksheet. It's referred to in the home learning schedule. Just follow the instructions there. Do the worksheet, but when you get to question 6, the problems are kind of like this problem. And these are tricky. They're not really year 7 level, but because you're in concept, I'm just trying to push you a little bit. Do what you can, but if you're sitting there for hours, I know you've got other subjects, so you're forgiven if you can't do all of question 6, all right? So make question 1 to 5 the priority, and then anything you can do in question 6 would be a huge, awesome bonus, okay? Thank you for listening. I have actually, for your final lesson this week, you have a mini assignment number 3, okay? So no new videos this week. All right, thanks guys. I'll catch you next time.